In this video, I want to start talking about counterfactual fairness. So there is a fancy version of the idea, and there is the version of the idea that's actually used in the paper. So let's first talk about the fancy version. And the fancy version says, well, I want to assign the same kind of premiums to an actual person and to a counterfactual version of that person who has the gender switched up to something else. Okay? Now, you cannot simply say, well, I'll take the person, I'll take all their characteristics, and then I'll switch male from 1 to 0, or from 0 to 1, or whatever. The reason you cannot do that is because if you apply the do operator to male, then that has implications for the distribution of red car. So you don't want to do that. You cannot just keep the red car thing fixed. So there can conceivably be kind of fancy mathematical ways of dealing with it. But the simple way of dealing with this is to just say, okay, so I'm not going to use male as a predictor. I'm also not going to use red car as a predictor because red car is caused by male. So if I switch the male variable to something else, that's going to be affected as well. So I'm just going to throw it out. Okay? So what does it mean? It means that basically all of that goes away. Can't use it anymore. But we can use this part of the graph because nothing here is caused by male, right? So there is no path in this model from male to aggression or from male to experience, male to danger, or anything like that. So this graph is okay, this graph is fair. So if we knew aggression, then we could use it to predict the number of accidents in a fair way. Okay, so that's the argument. So how is it gonna go? Well, we're not using male, we're not using red car. What we can do is we can predict aggression by looking at the training data and at the characteristics of a new person. You can kind of see how it would go. So let's say that both being male and aggression causes you to buy a red car with kind of higher probability. So what you would say is, when estimating the aggression, you would say, and that you get from the training set, right? So what you do is you say, okay, so if you have a red car and male is equal to 1, then your estimate for aggression is not going to be as high as if male is 0 but red car is 1. Why? Because male equals 0 does not explain the red car, so you say, oh, well, like on average aggression is going to be higher. Now, you might think that this is not fair either, because what you're doing is you're estimating aggression by looking at the gender. And that might be a good argument, so this is certainly not fairness through unawareness, right? On the other hand, mathematically, on average, this is the right thing to do if you want to, on average, correctly estimate aggression. Now, in this example, your estimate of aggression is not just going to be very good. If you have other variables that cause aggression, then your estimate would be better, and you'd just be making a small correction here. So that makes sense. And now the prediction is going to be fair in the counterfactual fairness sense if you're just using, aggression and experience, because those are not caused by any sensitive characteristics. So those are not caused by gender in this model. So that's the basic notion of counterfactual fairness. The technical difficulty here is actually inferring what this aggression variable is.